Welcome to the 40th edition of the Quintology Files. Is DNA homegrown or planted on Earth? By accident or by God? We know all forms of life on Earth use DNA as their operating system. We know that the basic building blocks, amino acids, may form spontaneously, and we have found some amino acids on inbound meteorites. Why did the Lifeform Operating System on this planet choose the four bases known as A, G, C, and T, their initials, to record the sequences of amino acids for each gene? If, as it seems, elemental compounds are predisposed to form the components of amino acids, and thence self-replicating organisms may eventually form from strings of these amino acids, why does every form of life on Earth use DNA? Logically, a family of different types of lifeform operating systems should have evolved. This points to the likelihood that DNA was planted on Earth. But was it planted accidentally or deliberately? By aliens or by God? Whilst DNA is ubiquitous on Earth, mankind's biggest question when we eventually encounter an alien is likely to be, are you powered by DNA? Planet Earth formed when our universe was already 9.3 billion years old, some 2/3 of its current age. Earth itself is now 4.5 billion years old. And for half of its life, Earth was utterly uninhabitable by any life form. The first single-cell amoeba are estimated to have emerged around 2 billion years ago. And the oldest multicellular life forms date back only 585 million years ago. That's almost 90% of our planet's current age. Life then evolved rapidly, a period that we name the Cambrian explosion, due to the sheer diversity of life forms that then emerged. However, during the repeated extinction level events, the vast majority of Earth's species were wiped out. Most forms of life became extinct, not once, but many times. Some extinction level events wiped out 70%, 80%, even as high as 96% of all extant species at that time. For more details about this, please view some of the very early episodes of this series, or you can look at my book entitled Prequel. Recent laboratory experiments have shown that amino acids might have formed spontaneously, developing on Earth billions of years ago. But the Earth was already 2.5 billion years old when we see the first single-cell life form. So amino acids only got the sequence right after 2.5 billion years of the planet being here. It then took another 1.5 billion years before the first multicellular organism emerged. This sounds like nature waiting to win the lottery. How many chances for amino acids to get into the right sequence were required for a binary cell to be completed? Incredible. This suggests the evolution of life is extremely fragile. But here we meet the most puzzling issue, that all life on Earth uses the same identical operating system, DNA. Surely evolution here on Earth should have created myriad different competing operating systems. This points to panspermia being our most likely origin, or alternatively, either aliens or God deliberately seeding Earth.
So every form of life on Earth uses DNA?
Yeah, absolutely. Even a bizarre new ecosystem recently discovered around some very deep thermal vents, about 5 kilometers down in the ocean, where around 100 completely unique species have been found, thriving without any light by metabolizing hydrogen sulfide. But even these species all use DNA to store their genetic material. Their DNA has an extra loop named plasmid that carries out special repairs to combat the extremely high temperature and concentrations of extreme poisons such as arsenic. Looking at the history of our planet, it points to one or a combination of the following events causing the development of life on Earth. Firstly, spontaneous evolution of amino acids. We have recreated the key components of life in laboratory experiments, replicating conditions on Earth a few billion years ago. Rock pools on the seashore, lashed by violent tides and incessant electrical storms when the Earth was young and the Moon orbited much closer, magnifying the tidal reach with multiple tides per day. In 2022, analysis of samples recovered from the asteroid Uruguru revealed portions of amino acids. Again, suggesting that amino acids can form spontaneously. The second probability is panspermia, the idea that a sample of DNA hitched a ride on a meteorite and landed here at a time when the planet was suitably terraformed, climatically terraformed. And thirdly, alien visitors selecting Earth as a suitable ecosystem for life, either from scratch or when some life forms had emerged, maybe to encourage the evolution of potentially intelligent life. The timescales for terraforming would vary enormously depending on whether one was just seeding DNA onto a sterile planet to breed amoeba, which would develop a suitable atmosphere, or introducing plant and insect varieties powered by DNA if weathering had already produced suitable soils.
Was that Cambrian explosion in species triggered by outside intervention?
I agree. It seems very odd. Whilst maybe it took 2.5 billion years for amino acids to join up in the right string to create single-cell organisms, and then for another 1.5 billion years, life on Earth was stuck with just single-cell organisms before managing to create even a two-celled life form. We then experience the Cambrian explosion of life forms around 580 million years ago. Maybe this points to an outside agent triggering the abrupt flowering of a complex ecosystem on Earth.
The timescales of human development also raise serious questions.
Yes, the first mammals appeared around 220 million years ago, but they had to keep their heads down through the age of the dinosaurs. Mammals only got their big break when a meteor hit the Yucatan Peninsula around 65 million years ago, wiping out the dinosaurs, except for the small birds. The next puzzle is that the earliest forms of bipedal hominoids can only be traced back as far as 5 million years ago. Yesterday in the evolution of our planet. And again, we find that human evolution had a very slow start. It took 5 million years for our ancestors to progress, fashioning different styles of flintstones into cutting implements. But then, in the last 140,000 years, the final variant of hominoids suddenly emerged, and in the relative blinking of an eye, during the last few thousand years, we've experienced an explosive spurt into an advanced civilization. Questions do arise from the excessively rectangular hyperbolic ascent of man. Looking more closely, conventional history teaches the ascent of mankind all happened in the last 6,000 years. From the first king of Sumer, Etana, crowned in 3760 BC. However, recent assessments and further discoveries of megalithic structures and other records are pointing to some civilized culture already being in existence at least twice this age, when the Younger Dryas period was triggered by a meteor impact in 10765 BC. So, we can see that life on Earth progressed painfully slowly. 2 billion years for a single cell organism, another 1.5 billion years for a 2-cell organism. Then the Cambrian explosion. Man's ascent seems similar, chipping at flintstones for 5 million years. Then, kapow! We develop technology and fly into space in just a few centuries. Has life on Earth experienced external triggers that ignited the sudden profusion of life forms in the Cambrian age, and again triggered the rapid ascent of mankind in the very recent past? Imagine, even a few centuries ago, if a machine flew across the sky, landed, and some beings emerged, they would have been immediately acclaimed as gods. Might some of the ancient myths and artistic representations be trying to tell us about some real events?
Did aliens visit Earth?
Let me give two answers. Firstly, the examination of ancient texts, including biblical, points to the possibility that we humans are ourselves aliens. Secondly, is life on Earth, i.e. DNA, itself also alien? We shall look at the evidence. If aliens have visited and intervened in the affairs of man, certainly if in biblical ways, with gods descending and fancying the daughters of men, then they too must have been DNA-operated life forms and also shared more than 99% of our DNA code. This would be staggering. It means that mankind previously visited Earth and had populated Earth eons ago. So we must be the abandoned outpost of a far older human civilization. One might speculate on a variety of human origins. Maybe DNA is the dominant operating system in the small and remote Orion arm of our own Milky Way galaxy. Remember, we now estimate that our universe contains over 2 trillion galaxies, so we'll still be pretty small.
What about panspermia?
Well, the other very plausible answer is DNA originated elsewhere, the panspermia theory. In 2019, a Japanese space mission retrieved samples from an asteroid in near-Earth orbit named Ryugu. Subsequent analysis revealed the samples contained 2 essential compounds used by RNA, niacin and uracil. Niacin is known as vitamin B3, nicotinic acid. Samples taken from 2 different sites on Ryugu both contained niacin and uracil. Whilst it seems unlikely that these compounds developed in situ in the sterile environment of an asteroid, the asteroid itself is probably the remnant of a planet or ejecta from a meteor impacting a planet. Thus, the origin of these compounds is likely to have been from a planet on which the building blocks of life had at least started to emerge. One can speculate whether the existence of these specific compounds points to something similar in function to RNA or DNA having evolved elsewhere. In 2023, the NASA mission OSIRIS-REx returned samples from another asteroid, Bennu. Analysis of the material returned revealed high carbon and water content, including a number of amino acids, nucleobases, and unexpected phosphate and magnesium sodium compounds. The samples, comprising 80% water-containing clay minerals, suggest Bennu itself had originated from a small, primitive, but ocean-bearing world. Again, this seems to point towards atoms being designed to assemble into the building blocks for life. The biggest near-term event for mankind will be the results of the analysis of the samples collected by the Mars Perseverance rover during 2021. Unfortunately, these samples may not be returned to Earth until around 2040, so we've got to wait a few years. Some astrobiologists believe there is a high probability of finding evidence of life on Mars. No one expects to find little green men running around, but finding evidence of any form of life will transform humanity. As we discussed in an earlier episode, 4 billion years ago, Mars was the pale blue dot, to quote Carl Sagan, in our solar system. It had a high oxygen content atmosphere. This oxygen, some still remaining as oxidized iron molecules, explains why we call it the red planet. Oxidized iron is the dominant colour. But Mars itself was doomed, as it lacked a big enough moon to keep its molten core liquid. And as that core froze, Mars lost its magnetosphere and hence its atmosphere and any protection from solar radiation for its life forms. But life is tenacious, and some life forms might have lingered below ground, or at least at the poles. In the worst case, there may be only fossil evidence left for us to find. The numerous missions to Mars, already analysing surface and subsurface materials, have revealed dozens of examples of amino acids, again suggesting they form naturally. We may well discover fossil evidence of life that existed when Mars had a good atmosphere and plentiful liquid water. The most stunning result will be to find that this life form used DNA as its operating system. That must be around 4 billion years ago, i.e. 2 billion years before DNA is believed to have existed on Earth. Given that we've identified a few hundred examples of Martian-originated meteorites which have landed on Earth, this would be tantamount to proof that we, indeed all life on this planet, is of Martian descent.
So we might all be Martians?
Not just humans, but all life forms on Earth. Alternatively, we might discover an operating system that is not DNA, which would point to life being likely to spontaneously evolve in many benign environments. Given what we're now finding on asteroids, it would be very disappointing if we found no evidence of fossils at all. If we find anything, it will be massive news. Martian organisms might use a different molecular structure. Perhaps they used a smaller set of amino acids for their proteins. When the results are announced, humanity will be on the edge of its most shocking discovery. There are 3 possible outcomes. Each will have a profound impact on our species. Despite the promising site, Jezero crater, and previous evidence that Mars had a balmy climate and plentiful water, no evidence of life is detected. This will be a great disappointment, but hope will remain for the future. Secondly, fossil evidence of DNA-based life is found. Many will conclude such life must have existed on Mars long before life could have existed here on Earth. Life here on Earth is in effect a Martian colony. There is a low probability that life has managed to cling on below the ground on Mars for billions of years after that planet lost its magnetosphere, its water, and most of its atmosphere. We will have found our cousins. Evidence of non-DNA life is found, proving DNA is not the unique operating system supporting life forms, prompting us to ponder what diversity our galaxy might contain. Whether or not we find evidence of life on Mars, various moons of our outer planets offer promising environments, in particular Titan, Enceladus, and Europa.
So we can use DNA as a shorthand for all forms of life on Earth. But how do we define life?
Interestingly, in its search for extraterrestrial life, NASA has done just that, developed a definition of life. Their working description is a self-sustaining chemical system capable of Darwinian evolution. NASA's astrobiology program has developed a novel and broader definition of life. A definition that encapsulates life on Earth, but also the possibility of life not as we know it. They've termed it life, but it's spelt differently. It's spelled L-Y-F-E. The fact that all life on Earth uses DNA as its operating system, despite the huge diversity of life forms, makes it likely that every living organism on Earth can be traced back to a common ancestor, probably an amoeba. Life on other planets may have emerged differently. Therefore, we need a broader definition. Two astrobiologists at the University of Washington have developed a new hypothetical concept to define L-Y-F-E, life. They define a living organism as satisfying 4 criteria. Dissipation, that's the ability to harness and convert free energy sources. Autocatalysis, the ability to grow or expand exponentially. Homeostasis, the ability to limit change internally when things change externally. And learning, the ability to record, process, and carry out actions based on information. With this definition, life on Earth is just one specific example of LYFE. To conclude, it does seem probable that we are all aliens. Indeed, in a few years, we may discover we are all Martians. I hope you enjoyed this episode. Please leave a comment and press the like button if you enjoyed it. Thank you very much.